Okay, in the last video, I introduced this idea of square roots and other types of roots. In this video, I just want to show some examples of solving square roots. So right off the bat, I want to mention that in order to be able to solve square roots, one thing that's really important is having your times tables memorized. And in particular, of course, having all your times tables memorized is helpful. But in particular, you want to know the numbers that give you a perfect square. So what do I mean by that? So if you have the first numbers 1 through 12, right? Usually when you learn your times tables, I think that's what they have you do is memorize, the times tables from 1 through 12. So let me write those out real quick here. 8, 9, 10, 11, 12. There we go. Okay, that's a weird 9, but it's a 9, I assure you. Okay, so what we want to think about here is for all of these numbers, 1 through 12, what if we square them? What do we get? So when we square 1, 1 times 1, that's 1. What do we get when we multiply 2 by 2? 4. 2 squared is 4. 3 by 3, 9. We say 4 by 4, or 4 squared is 16. 5 squared, 25. 6 squared is 36. 7 squared, I guess this isn't working out. I wanted to have everything underneath. Well, maybe I can do that. Let me see if I can save it here. So we have a 25 there, 36 there, 49, right? 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. So what I just given you here, or what we've worked out together, is these are called the perfect squares. And they're called that because if you try to take the square root of any of these numbers, you'll get a nice, clean, whole number as your answer. So what do I mean by that? Well, if we took the square root of 4, right, we know that's 2. 2, not 2.5 or 2 point some number, it's just 2. And a lot of times that doesn't happen. It only happens when the number here that you're dealing with, the area, right, is a perfect square, like 1, 4, 9, 16, any of these. It goes all the way up. You don't have to stop at 12. We just do. But this goes off to infinity, right? You can take as many numbers as you want, multiply it by itself. But at least try to have these ones memorized. And so the perfect squares are usually easy to find the square root of because they have nice whole numbers. And it's more of just like a memorization kind of thing. You just need to remember what number that is that gives you that number. But not all numbers do that. Not all numbers give you a nice, clean answer. So, for example, what if you had the square root of 12? Well, look at this. 12 is between 9 and 16. So that means it's not 3 and it's not 4. It's something in between 3 and 4. Well, what's in between two whole numbers like that? Fractions or decimals. And so this answer is going to give you a decimal. And it's going to be a decimal between 3 and 4. So the answer is going to be like, the answer is going to be something like 3 point, something after that. Actually, why don't I quickly punch that in the calculator just so we can see what it is, so you can see what I'm talking about here. So the square root of 12, it's, it keeps going on for a long time, so I'm just going to round it to the first 2 decimal places. It turns out that the square root of 12, if you round it, is equal to 3.46. And it keeps going on. It's like 3.464101, 64. It just keeps going on forever. So we could say it's approximately equal to. So actually, I'm going to write like the equal sign with the little wavy bar above that. That means it's like approximately that number. And I say approximate because I rounded here. I didn't list the whole number because I can't. It literally goes on forever. Okay, so that's what happens when you try to take the square root of a number that is not a perfect square. It gives you a decimal. There are methods for solving that, but I'm not going to cover that in this video. I will tell you, if you have access to a calculator, use a calculator to solve it much faster. So what about, let's actually do some. So I'm hiding the perfect squares. So now if we say, okay, let's do this, the square root of let's do 81. So hopefully you recognize 81 as being a perfect square. And hopefully you know that 9 times 9 gives you 81. So therefore the square root of 81 is 9. Remember, that's like saying if you had a square with area of 81, what length do its sides need to be? They need to be 9. Okay, let's look at another one. What if we have the square root of 121? Hopefully you recognize that is a perfect square. 121 is a perfect square, and its square root is 11. So 11 times 11 will give you 121. Therefore, the square root of 121 gives you 11. Okay, let's try the square root of, let's see, 72. And hopefully you realize right off the bat, that is not a perfect square. That is not one of our numbers, right? We have, let's see, we have below that is 64, and above that is 81. So 8 squared gives you 64, 9 squared gives you 81. 72 then is some number in between 8 and 9. So it's going to be a decimal of like 8 point something. So we would figure that out on a calculator. So I'll just say, at least for now, you know, use calculator. I don't feel like shifting the screen just for that. So, of course, you might be mad because you're saying, no, show me how to solve that. That's not what this video is about. It's not showing you to show you how to solve non-perfect squares. It's showing you how to solve the square roots of perfect squares. And one other thing I wanted to go over is maybe throw a little wrench in your game here. What if you had the square root of 1/4? So I just probably, just rocked your world there. I was doing whole numbers this entire time. Not once did I ever hint that you could have a fraction. But it turns out, of course, you can have a fraction. A fraction's a number, right? Just like any other number. And it turns out that the square root of that is 1/2. Now, how is that 1/2? Well, remember, the number inside, you're saying what you're looking at it, and you're trying to determine what number, if I multiply it by itself, would give me this number I have underneath. Well, look at this. 1/2 times itself gives you, well, fraction multiplication does not require common denominators or anything. It says multiply the top two numbers and divide that by the product of the bottom two numbers. So we have on top 1 times 1 gives you 1. The bottom you have 2 times 2 gives you 4. And that's it. That is the square root of 1/4. And hopefully you picked up on this, that we could have simply said, what's the square root of 1 over the square root of 4? And had we done that, we would have got on top, square root of 1 is 1, and square root of 4 is 2. And that actually sort of opens up this idea of one of the properties of square roots, where if you have a fraction and the whole fraction is under the square root sign, break up the square root sign. You take the top number, you take the square root of it, and the bottom number, you take the square root of it. And why do we do that? I could show you another rule using exponents for why that works, but we can look at it right here when we do the multiplication. 1/2 times 1/2. Well, we are multiplying or squaring the top number, right? We multiply by itself. We are squaring the bottom number. They don't need to be done together, right? You're squaring them independently. And so that's how you can solve the square root of fractions. You just simply break up the square root. So, for example, what if we had the square root of 9/4? Well, we say that that's equal to the square root of 9 divided by the square root of 4. Well, the square root of 9 is 3. Square root of 4 is 2. And that's our answer. And if you don't buy that, multiply 3 halves by itself and you'll get 9/4. Okay, so now you're probably, well, hopefully wondering how any of this relates to this whole thing from the last video about a square, like an actual square, right? Remember I talked about a square having some side length, right? And then every side had the same length, right? And then I talked about dividing that square up to get the area. I said to get that space, we divide the square up equally to 1 by 1. So we divide it however many times we need to, right, to get 1 by 1 square. So this, the way I divide it here, I'm assuming that was 2 here, right? But if that was 3 or 4, you know, if it was 4, we'd have to divide it into 4 equal spaces like this, right? But why does it work when we're talking about fractions when I said you want to divide these up into 1 by 1 squares? Well, it turns out we can take square roots of fractions, so there must be a reasonable answer for that. And the reasonable answer is this. Yeah, you want to divide up squares, so when your length is larger than 1, you want to divide up your larger square into a bunch of 1 by 1 squares. But what if you have a fraction? Well, we need to actually start with a 1 by 1 square, right? We start with a 1 by 1 square. Actually, I'm going to draw it a little bigger just so I can, for demonstration purposes, let me move down here. So I'm try to draw a nice-ish square. So I guess that's good enough. Okay, if this is 1 by 1, what if I wanted to make, you know, this in, what if I wanted to divide both dimensions up in half? So what if I did this? Cut it right down the middle, and on this dimension I cut it right down the middle too. Well, then if the whole total length is 1 and I divide it right down the middle, then that means, you know, one side of this, so I'll do it in a different color here. One of these squares from here to the middle is going to be 1/2, right? That's half of 1 is 1/2. And then again, this is going to be 1/2. And then same thing going in this direction. That's 1/2. And then from there to there is 1/2. So see what I did there is I broke up a 1 by 1 square into halves. And now I want to say that if I start with a 1 by 1 square, but I want to know what happens when I have a square whose side length is 1/2. Well, let's take one of the smaller squares from this 1 by 1 here, okay? Because I want that, because why? It has dimensions of what I want. It's a 1/2 by 1/2. So let's pull that out over here, and we have a 1/2 by 1/2. And I want to know what the area of this is with respect to squares that are 1 by 1. Well, notice that the area in here is the same amount of area if I took a fourth, right? This is 1 out of 4 squares of a 1 by 1. So actually this area, we're not going to break this 1/2 by 1/2 into smaller areas, right? Because it's smaller than 1. So what we do is we take a 1 by 1, we break it up into as many squares as we need to get our dimensions that we are looking for, like a 1/2, and we see how much area of the 1 by 1 square does that take up. Well, we see that it takes up a fourth of the 1 by 1. So it's a little bit different than doing a square with larger dimensions than 1, because we're able to break those up into 1 by 1 squares. In this case, we start with the 1 by 1, we break it up into as many squares as we need to get the dimensions, 1/2 by 1/2, and we're saying, look, we want a quarter of the area. So, okay, well, what if I had, let's see, what's the next smallest one? What if I had an area of 1/9? So what if I took the square root of 1/9? How could we think of that, right, in terms of a square? Well, maybe this will help demonstrate it. If we start, I'm going to try to do this semi-nicely. So if this is a 1 by 1 square, I want 1/9 of this area that's in here, because this whole area is 1, right? You have one 1 by 1 square fitting in a 1 by 1 square. But I want to break this up to where I want to see how much of this gives, how much is 1/9 of all that? So it turns out that if I break this up into thirds like this and like this, I have how many small squares in there? 1, 2, 3, 4, 5, 6, 7, 8, 9. And I want 1/9. That's right here. How big is this little square then? Well, if I had a length of 1 here, I'll do this in a different color. If I have a total length of 1 from this side to this side, and I break it up the way I did into equal spaces, then I broke it up into 3 separate ones. That means this is 1/3 here. And if I did that direction, I did it in this direction too. And that is also 1/3. And so I've broken it up and gotten that the area of a 1/9, or sorry, the area of a 1 by 1 square that gives you 1/9 is a little 1/3 by 1/3 square. That little square has an area of 1/9 of a 1 by 1 square. Therefore, the square root of 1/9 is 1/3. And we see that if we had just taken the square root of 1 on top, divided by the square root of 9, that's what we would have gotten as well. So hopefully that's helpful. Hopefully now you see that you can take the square root of not only whole numbers, but also fractions. Okay, I'll see you in the next video.